Although the Studio 5000 Logix Designer application includes a multitude of instructions, there are instances when it would be helpful if we could create custom instructions. The Logix Designer application supports this capability via add-on instructions, which are also known as AOIs. The add-on instruction folder is located within the Assets folder of the controller organizer. To create an AOI, we right-click the folder and select New Add-on Instruction. Within the dialog that appears, we begin by providing a unique name for the AOI. We should keep in mind that this name is how the instruction will be referenced within the Language Element toolbar. As such, the name should be a short abbreviation, along the same lines as pre-programmed instruction names, such as XIC, MOV, or ADD. Optionally, we may provide a brief description explaining what the AOI does. This description should likewise be brief, as it appears over every instance of the instruction in Logic. Any detailed assistance we may wish to provide may be included within the help for the instruction. From the Type dropdown, we choose the language in which the AOI logic will be programmed. An AOI may only be programmed in one specific language. The language can be ladder diagram, function block diagram, or structured text. AOIs may not be programmed using the sequential function chart programming language. Next, we configure the major, minor, and extended text fields to specify the relevant revision. Optionally, we can provide notes specific to the revision. Finally, we may, if desired, indicate the vendor of the particular AOI. The checkboxes at the bottom allow us to choose if we want the definition or the logic editor to open upon creation. In this example, we will choose to have the definition open and click the OK button. Within the AOI definition, we see that we may create parameters and local tags. The concept is similar to program parameters and local tags. So, for data that must be brought into the AOI, we create an input parameter. For data that must be sent out of the AOI, we use an output parameter. For data that is used strictly within the AOI, we use local tags. Additionally, it should be noted that parameters for array data must be represented with an in-out parameter. So, within the Parameters tab of the AOI definition, let's create our inputs and outputs. In this example, we would like to create logic to multiply two 3-element vectors. We therefore require two 3-element arrays as the inputs and one real as an output. As mentioned previously, the arrays must be in-out parameters, while the real can be an output parameter. These parameters are required, as the instruction logic would not be able to function without input data and a place to write the output. Thus, the required invisible checkboxes are checked. We know that, for this particular operation, we need to multiply the 3 pairs of elements and then add them together to arrive at a scalar. So, to store the multiplication results, we can create 3 local tags. Then, since we can only add 2 of the tags at a time, we create a local tag to contain the intermediate sum. Clicking the OK button applies our changes and closes the definition. Now we open the logic editor and begin programming our logic. This is a pretty simple example, so we won't dwell on the logic. We begin by writing zeros into the local tags. Then we multiply the 3 pairs of elements from the vectors. Finally, we add up the products and arrive at the solution. With our AOI complete, it is a simple matter to put it into use. AOIs are added to logic just like any other instruction. So, for example, we can use our insert key to open a browser from which we can add the instruction. We can also go to the Add-on tab of the Language Element toolbar and drag the instruction onto the rung. Once the instruction has been added to the logic, we have to provide a backing tag to contain the data within the AOI. This backing tag is of the add-on defined data type that was automatically created concurrent to the creation of the AOI itself. Then we enter the array tags from which the AOI reads the vector data, as well as the reel into which the result will be written. We can, of course, create these from within the editor, just as we would any other tag or program parameter. Having resolved all of the errors, we can now download to the controller and test the logic. Three different sets of data are all computed accurately with no resulting faults. We can, of course, test further, but it appears as though our new instruction works quite well.